Hi, this is Bhaskar. Today I am going to give the lecture on classifications of signals. So before classification of signals, first of all, what is signal? So in general thing, signal means which carries some information. That is whatever it may be. But coming to in mathematics, so signal is a function of independent variables such as time, distance, temperature, pressure. So these are the few examples of signals. Now signals can be classified into continuous and discrete time signals, periodic and non-periodic signals, causal and non-causal signals, deterministic and random signals, even and odd signals, energy and power signals. So these are the classifications of signals. So coming to first one, continuous and discrete time signal. A signal is said to be continuous time signal which varies continuously with respect to time, that is called as continuous time signal. For example, speech signal. So here the time is various continuously with respect to, here the amplitude is various continuously with respect to time. So continuous time signals is always represented with t only, either x of t, y of t, z of t. So that is continuous time signal. The best example for continuous time signal is speech signal. Next, discrete time signal. A signal is said to be discrete time signal, so which has discrete instant of time. That means for a particular instant, that is for a particular value. So that is called as discrete time signals. See, discrete time signals is always represented with n. That is x of n, y of n, z of n. So here n is a time, that is discrete in time. N is a discrete in time. So the best example for discrete time signal is stock market exchange. That is the best example for discrete time signal. So coming to energy and power signal. So energy signal can be defined as E is equal to integral minus infinity to infinity x square of t dt. That is in continuous. So coming to in discrete, so E is equal to summation is equal to minus infinity infinity x square of n. So energy signal has finite energy. Next, coming to power signal. A signal is said to be power signal which has finite power. That is, power is equal to limit t tends to infinity 1 by 2t integral minus t to t x square of t dt. In terms of discrete, power is equal to limit n tends to infinity 1 by 2n summation n is equal to minus n to n x square of n. That is for power signal. Next one, energy and power signal. Sorry. Even periodic and aperiodic signal. A signal is said to be periodic if it is satisfy the condition, that is x of t is equal to x of t plus capital T. So here capital T is the fundamental time period. That means the same time period will repeat again and again. That is a capital T. So here, so T is equal to, 1 by T is equal to F. That is fundamental frequency. So see the, for example, see this diagram. So here capital T, that is capital T naught is a fundamental time period. So this same time period will repeat again and again until the signal will end. So that is called as periodic signal. So coming to in discrete, so x of n is equal to x of n plus capital N. Here also capital N is a time period. So the best example for periodic signal is heartbeat signal. Next one, aperiodic signal. A signal does not repeat itself after a specific interval of time, that is called as a periodic signal. The condition for a periodic signal is x of t is not equal to x of t plus t. In terms of coming to discrete, x of n is not equal to x of n plus capital N. The best example for a periodic signal is speech signal. Next one, deterministic signal. A signal is said to be deterministic if there is no uncertainty of its amplitude and time. That is called as discrete time signal. That is called as deterministic signal. So it can also be defined as A signal can be represented in mathematical equation that can also be called as deterministic signal. So this is an example for deterministic signal. So next one, random signal. So if there is uncertainty with respect to value at any instant of time, that is called as random signal. So non-deterministic signals are random in nature, hence they are called as random signal. So the best example for random signal is noise signal. See, random signals cannot be described by any mathematical equations. So this is an example for random signal. Next one, even and odd signal. A signal is said to be even signal if it is satisfies the following condition, that is x of t is equal to x of minus t for all t. In discrete, x of n is equal to x of minus n for all n. For example, x of t is equal to t square. Example, x of t is equal to t square. If t is equal to, that is x of t is equal to t square. Next, if t is equal to minus t, that is also minus t whole square. That means this is a even signal function. That is example for even signal. Next, odd signal. A signal is said to be odd signal when it is satisfies the following condition, that is x of minus t is equal to minus of x of t. Example is sin t. Similar to discrete also, x of minus n is equal to minus into x of n. Let's see the example. X of t is equal to sin t. Next, x of minus t, that is equal to sin of minus t is equal to minus sin t. So here x of minus t is equal to minus of x of t. The condition is satisfied. So it satisfies the odd signal. So that is the example for odd signal. Next, causal signal. A continuous time signal x of t is called as causal signal. So which satisfies the following condition, that is x of t is equal to 0 for t less than 0. So that is called as causal signal. So here causal signal does not exist for negative time. That means the best example for causal signal is the unit step signal. So unit step signals exist only for greater than 0. Greater than 0, the amplitude is 1. So that is the example for causal signal. Similarly, for discrete time signals also, x of n is called as causal sequence. The sequence is equal to x of n is equal to 0 for n less than 0. So this is an example for causal signal. Next one, anti-causal signal. A signal is said to be continuous time signal x of t, which satisfies the following condition. So x of t is equal to 0 for t greater than 0. That is called as anti-causal signal. So anti-causal signal does not exist for positive time. That means it exists only negative time only. The best example for anti-causal signal is time reversal signal. So time reversal signal means what? That is, suppose if you are going to consider u of t, for u of t, time reversal signal is u of minus t. So u of minus t is exists in negative time only. So that is an example for anti-causal signal. Next, coming to discrete, a signal is said to be discrete time signal. It satisfies the following condition, that is x of n is equal to 0 for n greater than 0. So that is a condition for anti-causal signal. So here also same. So discrete time signals also same example. So here also x of n is equal to 0 for n greater than 0. That means here for greater than 0, there is no value. That means there is no exist. So only for less than 0. So the signal will exist on only negative side. So that is anti-causal signal. So this is the classifications of signals. Okay, thank you.